Hey everybody, welcome back to Young Engineers of Today. Hey Mateo, hey Cohen, how you doing? Um, I hope you guys had a good weekend. Uh, we did interesting, fun stuff. Um, good. Yeah, so anyway, we're going to continue with Inkscape. I'm going to do a little bit more lecturing today before we get started on what we're actually going to be doing today because I want to spend some time explaining why we're doing what we're doing exactly. So for that reason, there's going to be a little bit of lecture involved. I imagine it will probably take around half the class, and we'll get started in about half an hour. Uh, though I am a terrible judge of time. Um, so who knows? We'll see. It could take 15 minutes. It could take nearly the entire hour. But we are going to be continuing with Inkscape. I already said that probably. If I didn't, it was probably pretty obvious anyway, considering the picture that's up here. Whatever. I'm being helpful. Okay, so we already know the advantages of vector graphics, right? Like we know about the whole fact that you can scale it and that it tends to be a smaller image file and that you can modify it after the fact, like change the shape of stuff. So yeah, like we know everything that there is to know about vector images. Yeah, like there's nothing else to know. Except I lied. Let me just go ahead and get down to the slide that I'm talking about. Vector images are actually very useful for many things. Okay. Yeah, duplication. That's right. Vector images are actually very useful for, well, for one thing, namely, and that is laser cutting. They're very useful for laser cutting. They're very useful for machining, things like that. And can anyone take a guess as to why? Because it's easier to cut and format. Yeah. Well, yeah. Okay, so definitely the fact that vector images are shapes and things like that uh, are a much more natural thing for a computer to create cuts for, like a laser cutter to create cuts for. However, there's actually yeah. It's easier to read. That's actually pretty much exactly what it is. So here, let me explain to you how a laser cutter can work. So basically, a laser cutter, a 3D printer, a CNC machine, a lot of these things work off of similar principles, and that is they're given a set of coordinates and they move to those coordinates with the tool or laser engaged or whatever in order to make very precise cuts. They are given spatial coordinates to move to. So like a 3D printer will be like, okay, so you've got your print bed here, right? And this might be X, and this might be Y, and then this would be Z. And it would be like, okay, so you start at 0, 0, 0, go to 10, 10, 0 with the print head on. And so suddenly you've drawn a line from here to here. And then you might have another command that has it go from here to here. And then it turns the print head off and it moves over to here. And it goes, I don't know, like that. And then it comes back and creates one in that direction. And suddenly you've created a simple shape with like 3 or 4 commands. And then you can build upon that. You can create like a little square in here, and you can start constructing a design out of it. so on and so forth. I'm getting a little carried away with my illustration here. I'm sorry, but you guys get the idea. Like it's sent a set of coordinates that it then moves to, and it's a very, very precise thing. Assuming that the machine itself is calibrated, it's a very precise, exact means of printing or cutting something. It's like if you had a sheet of, like, just a big sheet of construction paper that had a grid on it, like graph paper, and you were told to draw things by moving to specific, basically drawing lines, even just straight lines to specific points on the graph paper. Yeah, it's like a tracer. Like even if you wanted to do, like, even if you can only draw straight lines and you wanted to draw a curved line, if your straight lines are short enough, if that grid is small enough, you will draw what to the human eye will essentially look like a smooth curved line. And you've done it by only drawing straight lines. The shorter the straight lines are that comprise the curved line, the more smooth and natural the curved line looks. It's like a trace of the cuts, exactly. So now you're given a set of coordinates. What does that remind you of? A grid, maybe graphs, a map, yeah. Now, what is the advantage of, let's say in our example here, we know this to be y equals 2x plus 1, to go back to that really simple graph example. Now, what is the advantage of knowing the equation to the graph? You can solve it. Exactly. You can plug in any number here, and by solving the equation, you get the coordinate here. Now, on a 3D printer, you work in 3 dimensions. On something like a laser cutter, you only work in 2. And so, sometimes you'll even get equations that look like this for your vector image. Since a vector image is working in 2 dimensions as well, all of your vector images are going to have like y equals blah, 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 or x equals blah, 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 blah. So they're all going to be solvable equations so that A, the computer can create them, and B, the computer can recreate them so you can share that vector image with somebody else. So you might see where I'm going with this. If we're given a set of solvable equations and we're asked to create a set of instructions which are comprised of grid coordinates to something that works off of that, you can imagine how easy it is for a computer to do that. So in essence, it is very, very easy to translate a vector image to something that can be cut out on on like a 3D printer, or excuse me, a laser cutter. So that's another advantage to vector images, is they lend themselves very well to physical constructors, like laser cutters, or there's one I'm thinking of right now, but it's not coming to me. So we'll just say laser cutters again and pretend that that's a different thing, like laser cutters or laser cutters. Yeah, I'm eloquent. Anyway, you can do really cool stuff like this. Like, look at that. Look at that lamp. Look at what it's projecting on the wall. Look at that. Look at how complex that is. And that was made by a computer. All somebody had to do was, say all that somebody had to do. All somebody had to do, even though it was a lot of work, was manually draw it in something like Inkscape. So they drew that tree design. Then they exported that tree design as an SVG file to something that can translate it into like a like a file that a laser cutter uses right now. I can't think of it. I think they use SVG files as well. They can also use PDFs. It really depends upon the laser cutter. Anyway, yeah, it is pretty awesome. It's a direct one-to-one translation of the thing that person drew on the computer, and they turned it into a lamp. Likewise, like for this headboard, something that was laser cut from uh, a uh, a vector image. I'm sorry, I'm not terribly eloquent right now. Now, the other thing about laser cutting is you can also etch with lasers. So, this was obviously cut out. The fabric was cut out. But you can also do etching. As opposed to just cutting all the way through, you can do etching or burning in order to create designs on a whole piece without cutting out other pieces. So like this Fab Lab Tacoma thing, that's etched onto the wood, burnt onto the wood. This house was cut out. The designs on these glass pieces are, or maybe they're not final, but sort of like Pyrex. Anyway, which is a type of tempered glass, but who's counting? Or like this image of this dude on this piece of wood that was burned onto the wood using a vector image editor. Here's a picture of how a laser cutter works. Just so you guys know, you focus a laser, put it through some gas to activate it, and it cuts. That's more or less the really simple breakdown of how a laser cutter works. Anyway, so stuff like this can be created in Inkscape and then just directly translated into something that you can cut out in on like a laser cutter. Which, by the way, is there anything that's like cooler than being able to use a laser beam to cut stuff out? Like it is a science fiction laser, but it's real. It's real, and we use it to cut stuff out of other stuff, to cut shapes out of wood, etch designs onto glass. It's a computer-controlled laser to shoot things with and cut stuff out with. But yeah, you can cut, you can engrave, and you can bezel or burn or whatever. Here's another example. We got this dude. This dude's picture, right? It got vectorized, and then it got laserized. Well, I mean, you can do it with a raster as well, but regardless, it was laserized. Here's some vector, basically some work in Inkscape allowed them to create the template or the pieces to a Ferris wheel. They're able to build that Ferris wheel out of balsa wood just by cutting it out with a laser cutter. And it's a fully working Ferris wheel. You'd be able to spin the Ferris wheel and all the little buckets would hang down thanks to gravity, and fully working Ferris wheel. Stick a bunch of Lego men in there. Have it roll so fast it rolls off the thing and off the table. Stick up a motor onto it. Hook up a motor onto it. Oh my gosh, that would be the best thing ever. Hook up a motor onto it so you can have it spinning at like 300 RPM. It wouldn't even make any sense. It would be bananas. It would probably jam up at some point. It would probably break and fly off. But you could try it, and it might run at 300 RPM for like a glorious half a second. You can engrave with vector. So as you can see here, that they actually engraved this scorpion design into the wood, and then burned the engraved parts to make it stand out more. Why you would want an engraving of a scorpion? Who knows? To each their own, though. Now here's the other thing. There are a bunch of different ways you can get different, as you can see here, this is a gradient of different colors and darknesses and stuff like that. And it's totally doable to do that, within reason, of course. So you can create a very light etching, or you can create a very dark etching. Once you start getting too dark, then it starts burning what am I trying to say? It starts burning the surrounding bits of wood, so you start getting some discoloration and things like that. But if you work with very light colors, very uh, either light power or a fast speed or both, you can ensure basically that you keep the discoloration to a minimum. But as you can see, this is just a graph. It's basically just the amount of power, 10% power up to 100% power, and the speed, 100% speed down to 10% speed. And as one might imagine, if you stay on an area for longer, you're going to transfer more heat to it, and if you hit an area with higher power, you're going to transfer more heat to it. So the slower you go, or the higher power you have, the darker you're going to cut. And once you get to a point where you're going too slow and the power is up too high, you're going to set fire to stuff. And I mean, obviously that's gonna differ from machine to machine, but this is just kind of a neat illustration of the kinds of results you'd get. Yeah, watch it go kaboom, basically. Or that was my terrible impression of fire. There, that was better. So as you can see, here's a direct example, something that was created in Inkscape and then cut out and then assembled, and you have like this weirdo sugar skull sort of layer cut design thing. I'm a jig. Anyway, it exists. And that's the end result you get, which is kind of cool. I'm sure it probably actually looks really good when viewed from right angles. So like looking at it head on or looking at it from the side, as opposed to this 3/4 view that you have here where you really see like all the layers, and it sort of destroys the illusion. But you might want to get that checked out. But yeah, by and large, you can do stuff like this. I know. So we already went over this. We already did this stuff. We already created our duck image, except it wasn't a duck image, it was a cat, and I broke my computer for it. We looked at the number of nodes, we resized the drawing, la. But yeah, we turned a raster graphic into a vector graphic. Pretty exciting, right? That was what we did on Wednesday. Rather, that's what I did, and then you guys chipped in with commentary and stuff like that. You might have done it as well, though. I don't know. So you can also 3D print your vector graphics. You can import them into stuff like Tinkercad and things like that. So this guy had his little bracelet thing. I guess he meant to turn it into a bracelet. I'm not entirely sure where he was going with that, but I assume it was a bracelet. And basically added a third dimension to it and 3D printed it in order to create the design you see on the right. So it started out as a thing on the left, and then it became the thing on the right. And yeah, I'm pretty sure that's a bracelet considering there's a break right here that's meant to like link together. Anyway, yeah, that's the bracelet. It does say love, 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 love. So this is how to convert it into a 3D printable thing. We're actually gonna skip over that for now. But it is totally doable to import it into Tinkercad and then just basically stretch the z dimension of it so that you have a three-dimensional object as opposed to a two-dimensional one. And then 3D print it. There's a lot of stuff covered on this slideshow. The Bezier tool. I think last year we did business cards. Also talked about saving it to GitHub. That was the thing. This is setting something up to be laser cut. Who here ever messed around with spirographs? One person? Okay. Okay, well I thought they were pretty neat. Granted, 1 p.m. to 4 p.m. on Saturday, October 15th. I don't think I work then. So, yeah, I can see about attending if I don't actually work then, because that would be pretty cool. Just to put a face to the name and all that kind of stuff. Anyway, yeah, 1 to 4 p.m. on Saturday, October 15th, the Department of Computer Science at UNC is hosting an open house for middle and high school students, just so you guys know what I was talking about. And I was responding to Caleb. So if you guys are going to that, maybe you guys can coordinate and meet up in person or something like that. Although from experience in previous classes, you guys probably already know each other pretty well. For some reason, a lot of you guys already know one another. Anyway, yes, spirographs, pretty neato things. Basically, the gear locks into the outer ring, and then you stick a pencil into one of these holes, and then you just sort of, trace the gear around it, and it drags your pencil, and it creates like a spiral design. Like it's like a woo 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 woo. I need a spirograph for this illustration, but yeah, like it'll create something like that, and then you can loop them so you have like these big like interlocking designs. And stuff like that, and it looks pretty neato. It looks a lot better than what I drew here. But yeah. As you can see, it's totally possible. Create something in Inkscape and have it get cut out. So anyway, here is, right at about half an hour, here is the project that we're going to be going over. So we're going to be taking an existing design that already exists, hence existing design, the Department of Redundancy Department. And we're going to add on to it. I mean, this is not that complicated or complex of a project, but really the whole idea behind this is we're going to be able to maybe, potentially, hopefully, I'm hoping, be able to get these designs cut out with laser cutters. So yeah, potentially get cut out with lasers. And in this case, it's going to be a cornhole board. How many of you have played cornhole? I'm sure a good number of you have, right? Yeah. No? Okay, so basically, so a few of you have, a few of you have not. Do you guys understand the rules of cornhole? Okay. Well, I'm not surprised that those of you who have played understand the rules. So basically what you have is you have two boards a certain distance apart from one another. And they're fairly big boards, and you might be standing behind them like, woo! This is you standing behind them. And these are the other people standing behind theirs. Now, the important thing is these cornhole boards have holes in them. And then people will have beanbags. Yeah, it's the game where you toss beanbags. Yep, that's the one. You got to toss them, and you either got to land it on the thing, or you got to get it in the thing. But the thing is, if you get it on the thing, and your partner also gets it onto the thing, then your points cancel out. So it's like you got to have all of them on the thing, and then all of the other ones in the thing, or whatever. But then you can like knock them off, and all kinds of wacky stuff can happen. Anyway, that's cornhole. Really helpful illustration. So what we're going to do is we're going to modify a cornhole board. Woo! Cornhole board so that it's got yeah, he controlled it with his mind. Yeah, exactly. Here we go. Is it going to land? Is it going to... No, it's going to fly away. It's going to come back at us. No, it's going to go back at you. No, it's going to just hover over the thing for a second and spin uncontrollably. No, it's going to land inside the hole. Quite a toss. Anyway, we're going to modify a cornhole board so that it has a little bit of your own personal touch on it. And in my example, it's going to be exactly. It's exactly like that. Don't play golf with Jesus. Yeah, I'll definitely send the link. Here we go. Let me go ahead and just copy link address. There you go. So in the chat box, there should be a link to the SVG file. Hopefully, if you click on it, you'll be able to follow it. And it's going to be the SVG file for cornhole board. And it's going to look pretty simple. Now you're going to look at this and go like, oh, really? That's it? But we're going to modify it. Wah! Wah! So what you can do is you can just either click the download button in the top right up here, or you can right click on it and save as. Nope, can't do that. Gotta click the download button. As you can see, sccornhole2.svg will download to my wherever I have it download, probably my downloads folder. You guys too, more than likely. Anyway, I'll give you guys a minute to download that. Okay, so presumably the file is probably downloaded by now. Raise your hand if it's still downloading. Okay, no hands. It's a tiny file. It's a tiny, tiny file. I'm going to open it. That's going to be wrong. I'm going to show it in folder. Well, we got a couple ways we can do it. I'm going to show it in folder, so here it is here. I can right-click on it and let it think about its life for a second. Open with Inkscape. You can also do open with and select Inkscape. Or you could open up Inkscape and then open up the file inside of Inkscape, one way or another. Close this out. Here it is in Inkscape, and it is exactly the size of our canvas. Almost. Mostly. It won't download. What do you mean? Is it saying something, or is it... Maybe? Well, okay. In the meantime, you might have noticed how I said it almost fits onto the canvas. You might be like, what do you mean? It fits perfectly. But if I am to zoom in, way in, you might notice some faint gray lines that appear. Those faint gray lines are the sides and the front and the back of the cornhole board, respectively. Sides and front and back, and sides and front and back. This is just the top of the cornhole board. We need all that stuff if we want it to, you know, stand up. Did you click the download link, or did you right-click on the file and select Save As? Because there's an arrow with a line in the upper right-hand corner. You want to click that. So you clicked on that and it downloaded as an HTML? Well, let me see here. Maybe we'll do that. So reload the SVG file and then try again to download it. Or try to download it again. Oh yeah? Was everybody else able to download it as an SVG file? Raise your hand if you were able to. Okay, excellent. Right, so you'll want to do the thing that I was doing before where I showed it in Finder, or showed it in Explorer. Basically showed it in Folder, and then right-clicked on it and opened it with Inkscape. Because if you just click on it here, it's just going to open it up in Chrome. Oh, no worries, Brendan. Just download the SVG file and open it up in Inkscape. We'll give everybody an opportunity to be able to do that. And let me know if that works for you, Cohen. No, I was not just making a strange noise with my mouth. I don't know what you're talking about. It still won't let you. Okay, try opening up Inkscape first then. And then opening the file through Inkscape. Did it? Excellent. All right. Glad to hear it. Okay, so cool. Now, presumably, pretty much everybody should have this open up in Inkscape. Bam. And like I said, if you zoom in decently far, you'll be able to see like the faint gray lines. And you'll be like, oh, okay, I see what you're talking about. Because you probably can't see it on my computer through the internet. I don't think the bit rate is high enough to be able to see that. Unless maybe like I zoom like way, way, way in. Yeah, you can see it there. But there are easier and better ways to go about this. Especially because it's going to take that long to scroll all the way across this whole dang thing. Anyway. Oh, there we go. Boom. Now you can see what I'm talking about. Whoops. Thank you for reminding me. So you definitely weren't able to see it because my screen was paused. Okay, so yes, this is what it is. Now, let's go ahead and add our own customization to it. Now, I'm just going to follow the slideshow, which I created. Then again, you guys can do whatever you want. Like, it doesn't have to be necessarily this design or anything like that, but this is just so you guys can see sort of mechanically how one might go about doing some of the things that you might want to do in order to customize this. So yeah, faint gray lines everywhere. These are for the laser cutter, so it can make a cutout not only for the board, it can cut out not only the board, but the structure for it to stand up on. So whatever you do, don't change any of those light gray parts. Just keep them as is, because those need to be there. Those are very specifically measured and very specifically included where they are and stuff like that. So let's start with a picture. Of course, you can use one of your choosing, but for purposes of explanation, I'm going to use the UNC logo. And everybody should be familiar with this. Do a Google search for your item, then click on images. Then we're going to make sure that it's an SVG image. So let's go ahead, UNC logo. Go to images, gear, advanced search, SVG, advanced search. So now we've got a bunch of UNC images. So let's go ahead and select one that appeals to us. Let's see, Ian, academic.ru, really, .ru. Yep, this is an SVG. So let's go ahead and we'll download this image. unclogo.svg. So once you find one that you're satisfied with, download it to your computer. Remember to save it in a place you can find. And then we're going to import it into Inkscape. This is very important. We have to make sure that it's an import. If we open an entirely separate file. If we import, we add a picture to an already existing file. You can download it by right-clicking on it and selecting Save As. And that will be enough to be able to do it. Save as image or link, save as image. You'll definitely want to save it as image. So yeah, again, once we've downloaded it, we'll want to import it. So that allows us to add an image to an already existing file. Otherwise, we create a whole new one. We open up a whole new file with that image in it, which is not what we want to do. We want to add this to an already existing file. So here we go. Here's the UNC logo, just chilling there on our cornhole board. Yours can be State or Duke or whatever, I ain't going to discriminate. This is just closer to, my personal experiences. So I'm going to go with that one. Add it by going to File, Import. So now we've got our image on our cornhole board. However, there's more that can be done with this. Like, for instance, the image is sideways. That's not ideal. That's not what we want. So let's go ahead and rotate it. We can rotate it by just clicking on, see how it's already selected, it's already got the dotted line around it. It's got the arrows. Clicking on it again, the arrows change. Remember how the arrows signify what you do. In this case, the arrows will resize it. In this case, the arrows will rotate it. So I'll hold down Control and rotate it, which allows me to snap it to, I believe, 5 to 10 degree increments. And we'll rotate it 90 degrees. So now we've got our UNC logo rotated 90 degrees so it's aligned with the rest of the board. Put it on a resize, hold down Control to keep the same proportions, and make it a little bit larger. Place it directly underneath the arrows, the chevrons, and there you go. We've added an image to it. We've already made this our own. Again, I'm assuming that the image that you're using is not necessarily the UNC logo. It can be if you wanted it to be. You are more than welcome to do that. But I imagine that everybody has their own ideas as to what they want it to be. So far, so good. We've got an image in there. However, we can do more with this. We can do stuff like add text. So why don't we do that? I'm going to go down here to our little text tool. Yeah, I'm just going to drag a rectangle there. And I'm just going to type go. Because down here is going to be heels. But go, and from here we can change the font, so we'll make it let's see here. Gentium Basic. Let's do like a nice. We'll use where is it? Impact, and we'll make it all caps. Whoops. Or we'll just delete the whole thing. We'll make it all caps. I'll give it a nice bold font. Actually, that's kind of appropriate for computer science. And I'll make it Lucia console. And we'll make the font even larger. Let's make it like 250. Too big. Too big. 200. Too small. 225. Nope, that's 2,225. 225. 230. It doesn't fit anymore. There we go. That's why. That's why. Let's try 250 again. Let's try 350. So far, so good. We're getting there. And just basically move it around until you've got it in a position you're more or less satisfied with. And then I'll go down here and I'll say heels. Because, you know, go Tar Heels. You'll see the console. We'll make it, let's try making it 350 again. It's a little bit big, but we can move it around so that it makes still a little bit too big. So maybe we'll bring this down to, let's say 300. Why did it make it 10,000? Wow, that is way too big. 300. There. So now we've got our text on here so far, but it's not ideal. Like the fact that the text is all facing the same way is not great. So what we can do is we can rotate this as well, so it's facing outwards. So now it looks a little awkward. Maybe we can rotate it back so they're all facing inwards. I don't know if that makes it any better. Rotate it back outwards. Well, one way or another, we've got something. We got something we can work with here. Maybe it ain't your favorite. Maybe you have better ideas. That's entirely possible and in fact encouraged. But maybe this is what you want to go with, which is also great. So there's probably some more we can add to this, but for now I'm going to go ahead and I'm going to call it a class, just so we can continue with this a little bit more on Wednesday, spend some time talking about it. And maybe add a little bit more to it then. At any rate, I'll go ahead and do the poll questions now. If you have any questions about anything, we'll leave it open to question and answer time afterwards, after the poll questions. And then if not, you're more than welcome to head out. So yeah.